recording at a more reasonable bitrate. And with MKV, that way it doesn't like hit huge and then crash. Okay, stream should be a lot more stable this time. But let's see, are we back? We are back. But yeah, so just more of me going, do I actually want it to be a stack machine? Do I not want it to be a stack machine? Do I want to let LLVM optimize the structure? Do I not want LLVM to be able to optimize the structure? Like, how do I want to handle this? I guess if I enforce... If I want this to be like super portable, it makes more sense for me not to let anything optimize the structures, aside from an actual optimization stage. Because that would mean like actually like, could mess up with any reflection features I want to add in the future. So we'll say only if we represent structs, not as LLVM values, but as like, actually like, the raw data. Like, just manually manage your own structs, no get element pointer, none of that LLVM stuff. Just raw pointer shenanigans. Then it's significantly easier to manage from a memory standpoint and from a virtualized stack machine standpoint as well. When is Brane VR going to be released? Well, it's already open source, so the code is already technically available, and I've posted binaries as well. However, the actual question you have is when will it be usable? And optimistically, we might be able to hold meetups in like 6 months to a year. Very, very optimistically 6 months. Probably closer to the year mark. When is it actually going to be usable? That's probably more of the 2-year mark. Right now we're just trying to get like the bare foundation working. Like right now I'm like refactoring how we actually represent scripting language commands at all. Indeed, foobar. We're just trying to get foobar working. And it do be foobarred right now. And so since I've decided that we do want to like fully go all in on, we're not going to represent structs in LLVM as structures. We are like going to go all in on like the commands we use are custom. We'll handle that ourselves. I wonder, when I generate debug info for stuff, I think I can still generate struct debug info and then set memory addresses as structures. Regardless of if they're actually... Yeah, because it's completely separate. Nice, LLVM. For once, one of your strange decisions actually makes sense. Okay, so continuing on with what we were doing, so let's do IR op. Code hurts my brain. I'm self-taught and I know good amount, but this is ancient hieroglyphs. Oh, it. Don't worry about it. I do want, like, the right documentation for myself here. That pushes value type onto our emulated stack. Load, let's see what they use here. So they have a pointer on the stack, and then that gets turned into whatever we're loading. So this... I'm actually going to do 3 slashes here, that way it actually shows up in our debug info. Or highlights. So if I do, I think it's either Shift K. Yeah, it's Shift K. It should. Yeah, see how in the little block it's actually giving my little thing, but it is formatting it. It's not treating it as actual braces. Future-proofing who needs comments when you can just refactor the whole codebase when it shows a bug. I mean, it was only 1 day's worth of bugs we're refactoring. I32 into... And then this store command needs 2, correct? Yeah, it needs an I32 pointer, and then a type. So we're just like, and I've said it many times, we're just blatantly copying the WASM spec. That will make it super easy for me to just remember what my stuff does, because it's like, oh, it's supposed to work like this, but not actually. But on the surface level, like this. You no longer need a member access, because structs aren't real anymore. We're moving all of that behavior over to the compiler, and not the actual client side of things. We will still send structure information in the intermediate representation. That way we can actually interface with the host operating system a lot better. Ooh, joy. Unary operator. We don't need this to actually inherit from anything anymore, since we aren't actually grabbing types anymore. I guess this would just be the type now. What I'm gonna do is anything that inherits from binary op. Oh, I might have gotten these out of order. Yeah. Public. Operator. Now we don't have to deal with that anymore. Just going to define that one out of order, just because otherwise I will forget it's not actually a binary operator. Thoughts on using AI LLMs to help code? They can be very useful, but they can also get in the way. In my case, I haven't bothered to actually set one up with Vim yet. I was using Copilot for a bit. It's very nice for boilerplate and repeated sequences. Like, it actually would help with this code a fair amount. But then when it actually gets into, like, the bulk of coding, it does, like, the actual decision-making portions, it can slow down a lot. I can't tell you how many times I footgun myself by actually trusting LLMs. Where it's like, I don't have the mental model of the code that it wrote. So I just assume that it works the way that I would have written it to work. And then, like, I can't find bugs because I assumed that the LLMs wrote the code the way that I would have wrote it. And it functions the way I would have wrote it. And then, of course, one part of it doesn't work the way I expected it to, and it blows up the entire thing. So add, subtract, multiply, divide, and then this is actually a remainder operator. Not necessarily mod. If we're copying this, it'd be rem unsigned and rem signed. But since we have types and those store the signedness of it, we don't actually need to define signed and unsigned stuff. I think this is a unary operator. Ran into that a lot, waiting on a smaller model that can manage to context a whole code base because it loves to mess up. I use multiple files. Yeah. Big 2, yeah, it does. That's just a modulus operator there. And I do want to rename these. I like prefixing all of these with like IR, that way I know like, oh, these are the operands from the IR group. Okay. And then... I think that fixes all of their names. Are these equal? This would be I8 or Boolean. Do I want to have a Boolean type? I8 works just fine. I think LLVM represents booleans as an I8 type. Maybe? Is it an I8? I guess I don't have an I1, so it would be an I8. Greater than, greater equal. Do I have to define? I do want to define what was I just muttering myself about? What is that I want to define? Oh, right. Less than, greater than, less equal, greater equal. Okay, so they like interlace them. So equal, not equal. Alright. Thank you for sticking around while you could, though. It is appreciated. I wonder what their naming convention. Ooh, do I want to do equal to 0? Am I smart enough for that? No, I'm not smart enough for that right now. And also the benefit of doing it this way is it's going to be really easy for me to copy the WASM specification when I'm, well, the WASM LLVM backend when I actually get around to making that, because I'm essentially copying the commands, so I'll be able to just clone their target and then modify it to suit my needs. And there will probably be a fair amount of modify. Lots of deleting, much head scratching, and a lot of what is going on here. Greater equal. Right, I was looking for logic not. So let's see where they're. Or XOR. I guess logic. Rotate. You can rotate into like bits. Like does it just shift them around? Oh look, there was more. I mean, I'm not even using these commands yet, so... all these logic types are taking up space that I'm not using yet. We'll define them later. We will define them later, but not right now. Now, do I... The things to call can be inferred from the function definition. So I'll just say types needed, types return. We'll just say consult function call sigs. And then the next stage, we'll just take ooh, this is See, here's I don't know how to handle this command. Because next stage consumes a number of variables on the stack. It's like kind of a variable argument thing, but not, because structures are no runtime load. I'll call it JIT side. Since structures are no longer JIT side, it doesn't have information about like what I'm passing into here. I guess technically this doesn't. Well, this has the function reference. So I guess right here, I guess I need to do id ref return structure type. So this would have the type that we are returning here, because it is valid to reference structure types from IR currently. So that's just a behavior we can carry over. So we just say this is the struct to return. Now, I'm not even sure if I want next stage to be returning structures. I guess it kind of makes sense. Do I have a load effective address? Return 0 or more values from this function. Instruction. Unconditional branch to the outermost block, which implicitly is the body of the current function. Oh, okay. So essentially there's a return block. Okay. Oh, that's like an inline conditional. That's cool. Is there literally not a load effective address? Come on, there has to be something. So we have get, set, all of these load operations. But how do we get the pointer to load? That's my question. There's the LEA instruction. This is essentially the ampersand operator in C++ is this instruction. You Yeah, you give it a you use it to get pointers, basically. Yeah. But why? I guess right now, what I'm trying to figure out is let's say that you're running a virtual machine and you want to return a structure you have here, but your function is already run, so there might be stack values still on the stack back here. Actually, maybe not. Maybe there aren't values on the stack that you don't want there. No, okay, yeah. Let's say you have, like, other local variables here, whatnot. And then you have the actual values for your structure here. Now, the way that stack machines work, these values here need to not be there, otherwise they are also part of the return value. So how do you pop these off of the stack? Or rather, delete them from the stack? So this drop just drops an operand. Unless the way that they handle local variables, the case of local variables, is literally just these get and set of local variables expressions here. And that way you never have local variables on the stack. But like the whole thing I was doing here was figuring out how to get all my memory on, like, that I would ever need to reference onto an allocated block of memory. That way, like, my pointer system would work correctly. But they don't even have ways for getting the current stack pointer. A pointer to a stack value can be obtained using the local get instruction followed by i32 const 0 and i32 add or similar. Oh. So the way that you get stack values is just like that. So I really need to figure out how this local get works. Difference between a stack and a register machine is essentially this. A stack machine pops values from and pushes values onto a stack. So for example, an add operation will pop the last two values off the stack and add them together, and then push the result back onto the stack. A register machine has some number of places where values can be stored, and operations reads and writes. And operations reads and writes to those registers. So add will take three arguments. Two that represent registers to read from the operands, and then one that represents the register write to. So that register machine is what I already have almost working. Problem with registers is there's no liveness analysis, so you need to have some code like that. R01 used after addition without a lookhead, you have no way of knowing, even in a single static assignment. Register machines like LLVMIR, where each register is written to exactly once. The liveliness of each register must be continually recalculated. This means that you have overhead associated with compilation. Knowing the liveliness of variables is extremely important for generating efficient assembly, but instead of the liveliness ever being calculated when creating the IR and stored as part of it, you have to recalculate this data every time. If the IR is entirely in memory, this isn't so bad, especially if your code is in SSA form, but it means that you have to do extra work for the same quantity of code. And it means that a streaming compiler like Firefox's Wasm baseline compiler is unable to produce good code. And of course, add liveliness to this analysis metadata to the machine. The liveliness analysis is only useful if your code is SSA form. If it's not SSA form, then the liveliness is extremely coarse-grained. Well, that's where WebAssembly comes in. See, WebAssembly has these things called locals. Locals are mutable variables that live for the lifetime of a function. Since WebAssembly blocks can't take arguments, they're the only way for a block to receive data from outside. But I thought that's what the stack was for. Include stuff like loop counters, the classic example for SSA defeating mutable variables. It also includes regular blocks. Can't read the result of the add above. Oh, so the point of Wasm blocks is that they scope everything else. Block result 32, local get 0. So the problem, usually a stack machine can be trivially converted to SSA with no liveliness analysis. An item on the stack is dead when it's used as the argument to an operator. No ifs, but even a pick operator can be thought of in these terms as long as the argument to a pick is compile time constant. Although generally the SSA conversion of a stack machine that includes a pick instruction would be implemented using ref counting, meaning a local variable. Here, I need to look at other stack machines for reference here, because apparently what he's referencing there is the exact thing that I'm running into here with, like, how do you get pointers to the stack? How do you do all these things that I want to be able to do in my bytecode that I don't think would, like, make it insecure. Like, it might just... yeah. I don't know what this whole thing with locals is, because you already have a stack. It's right there. And you're, like, adding stuff to the stack. That's what it is doing. Unless it's not actually using WASM memory for that stack. This essentially makes WebAssembly a register machine without liveness analysis. Not only that, it's a register machine that's not even in SSA form. Both of the tools at our disposal due to optimization are unavailable. In a true optimizing compiler, we can't recreate that information, but WebAssembly was already emitted by a compiler that generated the information once. There's technically no reason why we should have to do that work again, it's just a deficiency in the language. A compiler that has to act on a stream of WebAssembly has less ability to recreate this information and will end up generating significantly worse code for essentially no good reason. Yay, we're justifying my WASM beef. For the most part, it's an extremely well-designed specification. However, they are weighed down by WebAssembly's legacy. WebAssembly started out not as a bytecode, but rather more like a simplified binary representation for assembly.js. Essentially, it was originally designed to be source code like JavaScript. There would have been a more efficient representation thereof, but it still wasn't a proper virtual machine instruction set. Then it became a register machine, and only at the last minute to switch to a stack-based encoding for their operators. At that point, concepts like locals were quite entrenched into the spec. Now, okay. See, but that kind of pisses me off, because like the entire point of writing a specification to be used by everybody is that you start you should start from scratch and go, what is the optimal way to do this? And then enforce the optimal way. You don't start with, oh, but it already was this way, and then like move closer to the optimal path. Now, if you're working with something like graphics architecture, that makes more sense because you have like hardware to deal with. But this is entirely a software problem, and it's a specification, so like that like everybody is adopting. So like, why at no point did it's a web technology. All web technology has so much legacy code. Like, man. This is a good article, though. I am dropping that into my Notion. I have to hide when I actually load my Notion, though, because it's currently on a different Notion board I don't want to leak. If I switch over to Brane, Brane script spec stuff. But yeah, apparently I was like, oh, the idea of a stack machine is awesome because it solves all these problems. I'll just copy the WASM spec because it's a stack machine. Indeed, indeed. I'm very cultured. But I was like, I'll just copy WASM because it's a stack machine. But apparently, WASM isn't a stack machine. It's got these local things. Okay, like locals. Let's actually stop, like, finish reading this, and then I'm gonna find an actual stack machine based interpreter and find its instruction set. When concepts like locals were quite entrenched in the spec. Not only that, but for the most part, the WebAssembly specification team were flying blind. No streaming compiler had been built yet. No compiler had yet been built. It wasn't clear that having locals would be problematic after all. C gets just by just fine using local variables that the compiler constructs the SSA graph for. Yeah, but those, they're on the stack. Ugh. It's only by working on a streaming WebAssembly compiler for integration with WASM time that I realized these issues, as well as more issues that I'll get into later articles in the series. Before then, I considered WebAssembly's decision to be utterly rock solid, and in fact I still strongly believe that most of the decisions made were the right ones. Although it has its problems, it's incredible how much of the WebAssembly working group got right, considering it was still such relatively unknown territory at the time of the specification's writing. What is the alternative? So currently, locals represent both function arguments and local variables. There's a proposal to allow blocks to have arguments in both functions and blocks to return more than one value. With this, it becomes possible to get rid of locals entirely. Loop counters are implemented by having the counter be given as an argument, and then when you jump to the header of the loop, you must have the new value of the counter on the stack. That's like a sifi function, but is much conceptually simpler. Since it's impossible to get the address of locals in WebAssembly, there's no need for the allocate in any form. Unlike in LLVM, you don't need to have locals at all. The only thing left is to implement function arguments by having... See, I do want to call this, though. That's how... Actually... Yeah. Since it's impossible to get the address of locals in a WebAssembly, there's no need for this. True, because this is local, actual stack memory. We don't want to use stack memory. We want to use the memory imported. The locals at all, the only thing left is to implement functions. This massively reduces the complexity of the WebAssembly specification and compilers for it without reducing the expressivity, allowing the compilers generating the WebAssembly to encode more of their knowledge about the original source into the WebAssembly itself. Although optimizing compilers will probably not generate better code from this, they will become much simpler and easier to maintain, and streaming compilers will become significantly simpler and produce significantly better code. Finally, not only is a stack machine like this automatically in SSA form, but it's automatically in a strict SSA form. This means that it is statically impossible to access undefined variables in WebAssembly. It exists now, you have 0 locals. Entering a function must be statically approved that the local is always set before access. This was in 2018, unless this dude hasn't updated this. You want me next where I tackle WebAssembly's problematic control flow. Oh joy, I don't want to have to deal with that. Or look at that. Okay, but how do return values work? That's still something I haven't figured out. either all locals need to consume down, like completely consume down to like either we need to make sure no locals survive at all, so the only thing left on, well, that's what we need to do, is just make sure that no locals survive, only the output value is what's on the stack of whatever was passed into the function originally. Let's look at stack machine interpreters. Wait, Java is a stack machine? I always thought it was registered based. Just because the intermediate representation is stack-based, it doesn't mean the generated machine code is stack-based, of course. As the code is converted from the intermediate form to machine code, it's basically recompiled, allowing for local optimizations. Wait, so like the JVM is a stack machine? Why am I copying WebAssembly when I could just be copying Java? How many opcodes are there? Oh man, imagine if David was in chat going crazy over Java mentioned. We don't need to worry about errors. Yeah, we'll figure it out later. Operation, a short description of the instruction. I love how they just have the format. Mnemonic equals the opcode, value 1, value 2, and then this is what it outputs. Cool. This song is so fun. Which song is this? If it says. Phantoms of the Asteroid. Array index is retrieved. Load reference from an array. I wonder if there's another site that has all of the opcodes. Ooh, that links back to the last page. So there's only 255 operations. It's not too many. Right, because it's an 8-bit bit code. Which apparently is all you need. Say what you want about the Java language itself. It seems like the language, it was designed well. Whether you like object-oriented or not. Because you see there's like bytecode here specifically for grabbing objects. Which I guess that also makes sense why it is a, like, garbage collected language. Is because you essentially, like, you have to garbage collect stack machines. They don't have a concept of stacked memory, I guess. There's no concept of an address here. Or pointers at all. But they do have concepts of references, which essentially are pointers. I guess... So the way that JavaScript, or just Java and C# handle... Because C#, if you don't know, uses the Java virtual machine. So when people say C# is Microsoft Java, it literally is. Like, it's using the Java virtual machine. It's ran the same way, but you paint it differently. The wall's the same. Load reference from local variable. Because this is kind of what I want. Wait, why is there... Huh? Why is there local variable 0, 1, 2, 3? Does Java have local variables? Push flow value 1. Or maybe these are just shorthands. Hopefully these are just shorthand. From local variable. But like that gives me a completely different perspective on like C# and just Java, knowing that it is a stack machine. Because like even Lua is stack based too, but I thought Lua used Lua has a registers concept as well. I can't read that in the headset. To values rather than to variables. Until 5.0, Lua's VM was a stack machine, used to operate against a single sequential growable stack of values, pushing and popping values. Here, since what AI is good at is matching patterns rather than, I guess, specific words, I'm not really sure to search for like the information that I'm trying to find. So you get to do we get to do AI stream. Hello, Chat GPT. You are now the streamer. Entertain us. But basically, I'm designing a stack machine. We'll just say that I'm designing a stack machine. It doesn't need to know that I'm actually like not going to run it as a stack machine. We're going to convert it to SSA and then JIT that. I'm not how to handle local levels. And read. When returning, copy the return values to the expected locations, then restore the stack pointer to the frame marker before returning. This ensures local variables are wiped while keeping the return values intact. Push a frame marker when entering a function, or use the dedicated base pointer register. Allocate space for local variables on the stack. When returning, copy the return values to the expected locations. Restore that stack. Restore that stack. Frame mark. I guess that is something that is technically possible, which is... okay. Yeah. If I have the ability to reference, let's say, I want to get the address of this bit of memory here. Then well, I know for sure I do want to be able to get the address of memory locations. So if we have... I'm fine with having one singular register that is the stack frame. So if we enter the function, we don't need to know about any of the stack that's up here. Let's allocate 2 local variables here. So these are essentially alloced, but they're not actually alloced. These can just be stored on the... This is our virtual memory here. There is actually like a stack that is the actual stack that's not the VM or the JITted code. Well, I mean, it could be the JITted code, but anyway, local variables, but they're on the virtual stack, not the real stack. So not the real stack. They are here. And then anytime we need to reference one of these values without fully consuming it, we would have a like load local function that would be relative to we could load stack. So we could load this value here. And now that value would be duplicated here, and then could be referenced this value push it here, and then we have it. So let's say we have some other data. So we do stuff, the stack gets filled up, we have a little bit of data here. Now, technically the stack shouldn't fill up, since we'll just be like value, value, consume values, value, value, consume values. So we won't really... Consume value, add up value, consume value, add up value, consume. If you were never able to set values again, I don't think I would have to account for local variables because everything would get consumed. However, we do have to account for local variables. So not everything gets consumed, because they're local variables that we still do need to reference. But we still want to be able to have references to these values. Structures are difficult to deal with. How does Blossom deal with? Is there a way to duplicate values? I wonder if there's a in-browser like Compiler Explorer. Can I get this to compile to WASM? Oh, here we go. WebAssembly Clang. Okay. So look, we can actually look at the WASM for things. So if we do... don't need to include anything, we can just do int. This is C++. Let's make it even easier. Let's do C. Oh right, because they just have values, so they would just load local multiple times. Oh wait, this is GCC. Okay, there we go. This is the actual... It's like here. Yeah, it just uses local get multiple times. So local get 6, local get 7, local set 8. And then here it does local get. It's interesting. Why does it do local set? Then what is dot lock do? Come on, this had like the ability to hover over assembly language commands and it told me what they did? Or is this debug information? No, this is local data, so these are the local variables. So when I say local get 3, it's getting 18. What? Here, this is number. One 318. What do these represent? So we can say local set 1. So this sets local 1. How's this getting local 4? There's only 3 indices. These are all our locals. Oh. And what's .lock mean? One, 2 to 0. 3 to 12. Oh, this is just the location of the code. This is debug information. This means nothing, so we can just completely ignore those. So we can say filter. Yeah, so this is what we actually need to worry about. I do want directives. So we can see these are all the locals. They're all I32. Global get stack pointer. So you can get the stack pointer. So we globally get the stack pointer. And then we set the stack pointer to 1 into the first local. Sorry, second local. So this is the prologue of the function. All of this is like secret sauce of how this works. And then this is the first argument. When we get num, see how it's like hovering, highlighting it there. So we local get 3. We load These arguments don't mean anything. I can't actually see it. So if I look at the load local, local set X. So this would set the local. The thing is, there's like a number next to all of the... Actually, these are arguments, I do think. Because this is pushing the constant 16 into here. So we're setting... So we're setting like the third local to 16. And then we're getting 1, we're getting 2. We're subtracting the 2 because the stack moves downward. And then we're setting wait, so we load 16 into 2, and then we immediately load 16 from that local. So you subtract the current stack frame. And the stack pointer isn't passed into the function, we're getting it from a global variable. So this has a global variable, which is the stack pointer. We subtract that. We then put the result of that subtraction into the fourth local here. Then we set... Oh, no, yeah, fourth. And then we get the fourth again immediately after setting it. Do we use it anywhere else? Okay, we do. So that does justify saving the value. If we're using it elsewhere. I just zoned out there. Let's see, where were we? We're setting the fourth one, we're getting the fourth one, and we're getting the first one. And we're storing that in... Well... The is memory binding to store it in. Maybe? Oh, there's a dark mode. Oh, that's much better. And then we actually get to the real function. Local get 3. And then from that we load every single load uses 12, so I'm gonna assume that's the memory binding. Local set. Oh. Okay, 3. We load whatever was pointed to by 3. Or 4. Which, honestly, this might be putting our argument right here. This might be putting our argument into the actual values. Is this... I-32... Is there any actual mechanism for this to... I don't know. One second, I will be back. But when I get back, I'm basically going to be searching how do pure stack machines handle mutable variables? Because that is my question that I can't figure out. How do you handle mutable variables? Let's hope my play space isn't too messed up. It's pretty messed up, but it's fine. So I recentered it last time, which means if I recenter it this time, it should be in the place it was before. I love this song. Okay, now... Go back to setting mode. Why am I standing like that? That's weird. Is it because I'm in a wall? Might be because I'm in a wall. Yeah. Come on. Why can't I walk? That's weird. I'm just stuck. Oh, was it because I had a menu open? It was because I had a menu open. Okay. Alright, back to being confused about like the thing that seemed very simple, like, oh, function arguments are on the stack, and then the only thing left on the stack after you return is what the function returned. Like, oh, it seems so simple. I guess the thing that I haven't thought about is that almost every stack machine when it's handling structures, it's treating them as entirely like garbage collected. And that way, like, when you return register value, like, the problem of cleaning up a function isn't hard when you don't have to deal with functions, or not functions, with structures. Because, like, how realistically are you supposed to dereference like, how do you put structure values on the stack? Stack handle. How do stack machines handle values? I don't care about data types. That's an easy answer. It's the instructions. Because if you keep it, yeah. See, what I'm trying to do here is I'm trying to keep structures entirely off of the stack. But no, I'm trying to keep them on the stack itself. But it's like very hard to do that. Okay, so what if I just gave up and keep register every single structure? Like, that solves my problem. Let's say theoretically I did that. I don't want to do that. I want heap allocated structures. I mean, I want stack allocated structures. It seems like the only way the stack machines... Yeah, when using multiple stacks, it becomes far easier to do everything. Maybe a stack machine isn't the way to go, unfortunately. That would have been so easy, but no, I do have to still figure out... If it had worked the way that it worked in my head, it would have been super easy, but it doesn't... The problem with the stack is it's very order dependent, especially structures. If I just heap allocated all of my structures, then it becomes significantly less hard. So I might actually... I've only built register-based virtual machines before, or just coding languages in general, so... That's what made sense to me. For register-based machines is what makes sense to me. Stack machines are very clean when working with individual arguments. However, it seems that they completely fail the instant you add in structures. Because structures, if you return a structure type, that is multiple values back on the stack, not just one return value. So then you would need to do operations on that struct to single it down to the single value that you wanted to operate on. And then after that, yeah. So I'm going to just go back to what I had before, which was this. It is nice having undo actually record all of that. But what I should do is be a lot more careful about how memory works. So what I'm going to change about this, and these were the main things that I thought the stack-based... What I thought stack or machine would fix. Getting pointers to local var types. Because everything would be on the virtual stack. Everything would be on the sandboxed pages. It's the main thing that I thought, like, I no longer have to determine where I'm gonna put the memory. However, it looks like the reason why all of these languages that I have dissed for being stack allocated, or not stack allocated, for garbage collected, the reason they're garbage collected is because dealing with structures on a stack machine turns out to be really, really hard, just even from a conceptual standpoint. So they just don't. They do stack machines. So I'm sorry, Udon. I will somewhat forgive you for not having user-generated structures. I will give you a very, very, very slight pass for that. Still pretty unacceptable, though. But that gives me a lot of context on why stuff is that way. Because there's something to do with the garbage collector, probably, that they can't instantiate new types. Or something like that. So it's hard to inject new types into the garbage collector runtime. That all makes a lot more sense now. It's still unacceptable from a dev perspective, from a developer standpoint. You shouldn't have user-defined types. But now I know the reason behind that, so I can intelligently diss them now. But what else did I think this would fix? The problem of local variables versus temporary variables. I didn't know how to deal with temporary variables versus local variables. Would be interesting to do an SSA form intermediate representation where every single operation that returns a value would create a temporary variable. Then you could put temporary variables manually into true variables if you want to. That solves that issue. I think it does make sense to pre-allocate return values still. Maybe. Still uncertain on that. Unless I want to have like one entire memory page entirely for return values. Is there any way I can remove the need for a destination value? I can make like a hybrid virtual machine. Implicit SSA values. Honestly, I think that's what makes sense. Is I'm going to get rid of every single destination value. We're no longer defining destination values. Move doesn't make sense in this system. Only the load and store ops. So load op takes a pointer. Store op also takes a pointer. Well, store would take a source value and a pointer to store it in. Member access, we're no longer going to do member accesses. We're just going to do straight add operations on pointers, and they'll work. Those pointers are secretly ooh, I don't know how I would account for overflows. I'll deal with that later. One of my friends just messaged me with the message, I can turn my PC off again, in all caps. And I have no clue what that means. Because usually it's the opposite problem of can't get it. Oh, wait a second. But back to this. We basically, my grand plan here is these values that we refer to, rather like these values that we refer to, actually refer to an instruction. Specifically, the value of a previous instruction. And if we do load, that's how we get like, yeah. I like this idea. I've never seen an idea like this one, so that is why I like it. I no longer have to name return values. Okay, so the Windows update made it so that... So, my friend, who said he can turn off his PC now, there's a Windows update that made his headphones stop working, so we reverted the update. But then Windows didn't give him a button to shut down without updating, so he just didn't. Because he has a very nice pair of headphones. For 2 months, apparently. Here in function, I'm still gonna have local variables. And the way that accessing structures from locals will work. Here's what I'll do. What if a return value is bigger than the input args? But right now, I'm still trying to figure out that same return problem. I do think it is a good idea for the return value of a function I think I am going to store all locals on the virtual stack. So I'm just going to get over my apprehension to doing that. We're doing it. So that means when we start up a function, actually, let's just say these are previous values. And then when we start the actual function, we get I don't want people to be able to directly access the stack pointer at any point, so we only have indirect ways to access the stack pointer, such as get local, be that, and locals, since we're not doing a stack machine, except for arguments, only arguments are stack machine. Only arguments. This means that it becomes easier to deal with. function arguments. Because, like... No, I want to stick with, like, the structure thing. It's like, oh, the call sig is, like, expensive to call functions. If we're passing arguments on the stack. It's the stack! It's fine! The stack is free! No allocations. Speedy. You are micro-optimizing. It's going to be thousands of times faster than Udon already. Like, we don't need it to be any more faster. Put stuff on the stack. It is fine to put stuff on the stack. Put stuff on the stack. Sorry, I just had to do that to myself, because I am, like, micro-optimizing at the assembly language level before actually writing code right now. If it's too slow, I can optimize it later or figure out ways to have it inline itself later. For now, it's fine to put it on the stack. Because that is literally the fastest memory that's not registers, and we're not doing registers because we want the call sigs of our functions to be usable by a host environment. That is a requirement. Therefore, we have to push stuff on the stack. Now, do we want to always put in 2 memory stacks, or do we want to keep it to 1? Because we could have 2 memory stacks allocated, and then I don't have to worry about I just, if we do 2 memory stacks, I just straight up don't need to worry about return values. Or if I have this, like, first function allocate more memory for return value, but I don't want to do that. Even though it will have the ability to allocate memory. I don't want to force an allocation for every function return. So, what makes sense is local variables go here. Any allocated structures also go here in our virtual memory. And then when a function returns. When a function returns. But are registers not used as stacks themselves? I recall them using them that way in my assembly class. No, I don't think that's how that works. Because registers are just single values. Like, they can't be anything more, anything less, and then a stack is a growing list of values. They can only be appended or added or removed to from one end. Sometimes you can read the values inside of it without like directly accessing the last element, but it is inherently just a list. So I guess well, I mean, when you're talking about function arguments, then yes, it goes from like first register to last register and then stuff on the stack, if you're going by like the C standard call method. But with the way that like JITted code interacts with the host runtime, I don't necessarily want to have to deal with like runtime binding functions. It's a lot easier to like be able to do reflection type things. It's a lot easier to call functions if they don't use registers as values. And I will basically need to call every single one of the functions inside a Brane script from the host runtime. So it makes sense to make the host runtime work well that way. Okay, I think I'll just have to bite the bullet and say whenever we want to return a value, we're going to allocate a struct here, then copy the values one chunk at a time to the beginning, and overwrite whatever else is there. But we don't need to worry about what is there because we're returning. So all of this is junk we don't need to worry about. So as long as we allocate one, and then push stuff back, then we don't need to worry about it. Just overwrite whatever the input value was. And this is better than the approach of the allowing us to like choose our return value or being asked nicely where our return. Well, I mean, in any case, they can't. The person writing the bytecode can't set the return value. But even then, I would just make it so it's like input, output, function. So I guess that's in the case of if we don't want to overwrite the input struct. But I guess if like I wanted to be efficient, it's just like pass in a pointer to a struct, which would be on the stack behind it, or somewhere else in a different memory. And that's like one value. That's nothing. I'm still overthinking this. It's fine. It's a stack value. Here, the load op will take in a pointer and a type. Perhaps. Hopefully not, though. So this will be able to infer type from the arguments. This will be able to just infer types from the arguments. This will be able to infer types from arguments. This will be able to infer type. This won't be able to infer types from arguments. That's why we have the native type. Then, since I'm doing all of that, do I need local variables? I don't think I do. So we're going to completely get rid of local variables until I add it back as debug information, potentially. I might actually add like IR operations specifically that are debug IR ops. That would be cool. Did I only delete stuff? I think I only deleted stuff. So we no longer have a move operation, because we're no longer using registers. It's only load and store. And removing that, yes, I like where this is going significantly more. Ooh, I do want one more operation that is load effective operation. And since the idea behind these memory stores is that we're fine with the script being able to access everything in the memory store. Like, we're just fine with that. Then it's fine if we're able to let it get addresses of stuff inside of there. Because that's the biggest danger of a load effective address operation. Does this actually load the effective address, though? So if we don't already have a printer, the stack pointer is passed in. I think for actually getting the addresses of things, we'll just have an implicit IR value 0 is the stack pointer. And since it is a... Since it is an IR value, IR values are going to be SSA form now, so you won't be able to set it. You'll be able to read it. And I think that's fine. So we just do a load on that value, add, and then that will get us the address of anything we would want. Value 0 is the stack pointer. That will be useful for our debug information as well. I wonder if I actually have to put it into anything. Well, in LLVM, I can say like, oh, this function argument, which is the stack pointer, is the stack. It is a value that people can debug, and then formatters can use that. Or variable decorators, I should say. So I can make debuggers that are actually good. Somebody's trying to convince me to switch to Bevy. Rewrite it in Rust. Must rewrite it in Rust. I don't know. I am like... Oh, there you are. Well, there he is. That's the guy trying to get me to rewrite it in Rust. But yeah, so there's a number of factors of, like... So, like, the main factor, I'll be honest, the main factor why I'm not currently using Rust is if I go here to just the Brane Engine repo, and then... let's just run this. Like, I have 21,000 lines of code, and I think this script is ignoring empty space and brackets. So it cuts it down by a couple thousand. So that, like, I have legacy code to deal with. That's, like, one not very good reason that I haven't switched to Rust. The other one is, like, the runtime for this language is LLVM orc, or ORC, on request compilation. And currently, there are no Rust bindings for that. So, were I to, like, make stuff work in Rust. I would need... What? Is this the orc bindings in Rust? I mean, that's definitely Rust. It's like C bindings. LLVM 4? Aren't we on LLVM 6 now? Third link? How well maintained is LLVM sys though? Dang it, that was my main reason for not going over to Rust. Now, like, going into Bevy, like, using Bevy is a hard sell for me. Because I honestly really want to create my own game engine, and just using Bevy kind of like steals that from me, to be honest. It is slightly an ego thing. Let's look at LLVM sys here. You can just use the ECS though. That's the thing, I am like very scared of using their ECS, because I'm not sure if I can get their ECS to work the way that I want it to. There's also a lot of multi-threading things I want to do. Right, and I would be writing a custom renderer. Because I guess you could just use the raw Vulkan API, like C Vulkan API, just directly from Rust, and it would be fine. Okay, yeah. There's Execution Engine. Does it have, like, LLJIT in here? Oh, it does have LLJIT. That's what I'm using. Cool. Honestly, a lot of the problems I'm having here is, like, I'm trying to write Rust in C++. Like, you can see this. How good is the threading support? I wanted to have a demo working in like 3 months. I guess switching to a different language, honestly, I'm more comfortable in Rust. Like, I would write it faster, because I already am. I'm not too far deep into this. Most of what I've done is design. Careful here, you'll actually convince me. Why not just use Rust instead of writing Rust in C++? Valid point. I'm scared because, yeah, I have a lot of code I've written in these other projects. I think, well, I could probably use the same tree sitter bindings. So I wouldn't have to rewrite the parser. I would just have to port code. The thing that I'm most worried about is that I was going to write a pipelines system. Like, the entire idea behind BraneScript was the fact that it was going to be like allow users a lot of control over multi-threading. What does Bevy do in terms of like multi-threading? Is the ECS just like have guarantees that it's thread safe, or does it actually have like a multi-threaded execution engine by default? Like, would the multi-threaded execution engine be something that I could write from scratch, or would I be forced to use Bevy's threading system? Like, if you say I can write my own threading system, I'm basically sold. Oh, that's not a beta version. LVM C API. So you can use org from C. Does Vavi force you to multi-thread, or is it single thread by default? So they do have ordering constraints. Guess I'm wondering, because the ECS was going to be slightly baked into how the because yeah, most of the scripting would be done in like Brane script, not in actual Rust. Your thingy is dynamic or not? I mean, it's very dynamic. It's runtime loaded. Nothing is ahead of time compiled. So I've heard that like you are able to do runtime components with Bevy, so that's not a problem. One thing is I wanted to give people like very explicit control over the ordering of asynchronous stuff. As like part of the language and runtime reloading, but that's something else to figure out. So how do systems work? Because essentially BraneScript was going to be the system scheduling method for Brane Engine in the C++ version. So my biggest conflict would probably be with this and how they're scheduled. Oh, let me... Oh dang, I do have moderation activity on. Heavy ECS. Does this purely an entity for each implementation. Like, you have a world of entities, and often require unique resources such as custom. Source is a special kind of component that does not belong to any entity. Okay, so these are like globals. Yeah, scheduling is what I would have the most beef with. So is scheduling part of this crate? Is ordering systems and then executing them on a world. So I'll kind of explain the idea I had with like how Brane script was going to work. Yes, single thread executor is an option, but here's the thing: I want multi-threaded execution, but I want multi-threaded execution in the way that I was going to define it with Brane script, which is very kind of abstract. The syntax of Brane script is essentially like a syntax for defining futures, to use Rust terminology. So you know how like async Rust functions compile down to a state machine that then gets sent off to an executor. Essentially, Brane script is it's an attempt at making something like that accessible to people who don't want to think about multi-threading. So the idea is create a language that everything in it is asynchronous. Like you don't have the option to do synchronous operations. The entire thing is built around asynchronicity by default. That means that the main concept of the language, there it is. Like, I sent this script to I sent this to Malik. so he's seen this. But not JavaScript. And I don't like the async keyword, because the async keyword is pretending that it's a synchronous function, when it's like representing a break in execution. So what I have is this even like, yeah, this is the final grammar I came up with. So instead of like the async keyword, I want to do like defined breaks. Go style colorless async. Is colorless async actually a term, or is that just like a reference to the fact I don't have highlighting on the custom coding language? But what I have is, instead of functions, I have pipelines. It is? Okay. Colorless async means that whether a function can suspend or not becomes an implementation detail and is no longer being reflected in the type system. No, I do not want it to become implicitly async. I want it to be very, explicit. I want it to be as easy as possible to know what's going on, because you explicitly define how it works. So I'll give you, I guess, I don't know if I have examples in this specifically, but for example, in BraneScript, there's no concept of a mutex based on, well, let me explain the concepts order one by one. When a system uses cooperative multithreading without async keywords or async functions. Maybe, sort of? But, anyway. Alright, I'm going to stop responding for a second and actually explain the full thing. So, pipelines are constructed of pipeline segments. So, these segments can have names, and full function signatures that define their arguments. But they can also just have implicit arguments depending on what's inferred from what goes to the next one. That's not important. Basically, first pipeline stage is implicitly has the same arguments as the pipeline. So this first stage has the arguments of the pipeline, and then it can do operations on those. And then it can either continue to the next stage. I think I might have changed continue to just plain next stage, because continue might get mixed up with other concepts. But we go to the next stage, and you can define the stage and also the arguments for that stage. So this value argument becomes what's passed into here. Or at least it should be. I might have these mixed up. This should be count value, because count is the output and value is what was passed into this pipeline stage. And it's not really shown off here. Actually, it is. So in this case, where I basically try to show starting two pipelines and having both these pipelines count. So this starts the pipeline add with these values. And the part that I want to show off here is that we have this shared 32-bit integer. So this is this would be the equivalent of an arc mutex. So atomically reference counted mutex. And then this is a lambda pipeline. I was getting crazy with the grammar here, but the important bit is I have a mutable reference to an i32. So the runtime of the language is able to implicitly go, oh, a shared i32 is passed in, but the value is a mutable reference i32. before calling this pipeline stage, we want to lock the resources it wants. And that's the idea I have, is anytime you do enter any pipeline stage, every resource that's required for that stage is locked all at once, so you completely avoid the possibility of mutex locks. Because all the data you need to fully complete the pipeline stage is fully locked at the beginning, and then by the time it's done, you're able to release all of them. Now, I do have ideas for a special bit of syntax that's like makes you not release mutexes in between pipeline stages, just in case that's something like you really need to do, but probably should be avoided because it could cause mutex locks. Undecided on that, but that'd be like part of like these dependencies and whatnot. Basically the idea is just very, very, very explicit flow of execution across asynchronicity, which is something that I find lacking in a lot of systems. And I'm also writing this in such a way that it could be broken out into a full like node scripting system. That's why like variable arguments are named very like Swift style. But I guess the one like last convince me of this, and I'll switch to Bevy, is that the way that I want pipelines to be triggered is that here's our like flow, this is our timeline of execution, and there's events on this timeline of execution, like essentially barriers. So like let's say this is when render. Say this is our render event here, and then this is the equivalent of update. This is our equivalent of update. This is our equivalent of render. So we have a bunch of pipelines that are spawned off of the update event. Some of these may interact with the ECS systems. Some of them may not. Some of them may interact with the ECS system, branch off, do a different thing, and then do ECS again. So they're like asynchronous systems almost. And then the render like pipeline barrier or vent, whatever you want to call it, could be forced to wait on some of these pipelines, and some of these pipelines could be allowed to run for multiple frames. It just depends on what is dependent upon them. And there's a lot of optimizations you can do here, like only allocating a certain time budget to run certain parts of this pipeline, so it doesn't take up as much processing power as the stuff you do know needs to happen within this frame. Pipelines are also non-blocking though. They can be non-blocking. You can explicitly set them to be blocking if they need to interact with, like, if there's something you need to do that requires them. So you can like have like the entire timeline of things that are happening wait on one pipeline, but in general, yes. I guess this could technically be like a main pipeline, even though it is still technically kind of asynchronous, since this would kind of be like stages, but you could dynamically insert new stuff in there, blah, blah, blah. Running for multiple frames implies that they are blocking. Well, asynchronously running on like worker threads for multiple frames. So this is stuff that's happening in the background. This is stuff that happens on a single frame that could be multi-threaded. So this entire like section here could happen multiple times. What I'm saying is like it looks like this where is it? Module schedule. It looks like the schedule module wants to do all of like this scheduling stuff for me, but it doesn't necessarily. I don't know how well it would handle these breaks in execution here. The systems in Bevy are non-blocking. You can fire events and also do async tasks also. Interesting. So, is system just an implicit hello, I'm currently being brainwashed into thinking about redoing this in Rust. System is just a function. Yeah, but I'm just worried about how the system is called and executed and what relies on the system being completed. Yeah, they're getting close, but there's still like a couple holdout, like, things I would need to figure out. I guess here's another thing, like, I don't want BraneScript to be dependent upon, I wouldn't want it to be dependent upon Bevy ECS. I would want it to be its own independent thing that could work separately, with the reflection and capability to be added into this system. So that, I guess that's the main thing, is like, if I was using this, I would want to use the scheduler as the base layer, but I want BraneScript itself and its scheduler to be the base layer. So my scheduler, I feel like, would kind of be in constant conflict with this, unless there's ways to, outside of the scheduler, to do entity component operations. Being silly and trying to speedrun a stupid game idea in 24 hours, that sounds like a lot of fun. I'm trying to get a custom coding language to work, and I almost got it working, and now I might rewrite it in Rust before I get it working. Honestly, with the state it's in right now, I could probably rewrite it to Rust pretty quickly. I'm not gonna lie. I believe you can do ECS without the scheduler. If I can do it without the scheduler, then it's very tempting. But the scheduler is how it figures out what stuff can be done in parallel, right? Is it possible for me to do, like, one-time ran systems? Like, here, run the system, it has these constraints, and it possibly has these constraints on other one-time ran systems, instead of, like, adding a system to be run always. It already knows from the type system. I'm gonna be dynamically loading new things. Is it possible to do that with the type system? Oh, you're saying that, like, with which components are requested, it does that. Okay. How easy is it to do entity component calls with runtime components? Because I know it's possible to do runtime components, but it, like, how easy is the actual API for, like, can I do it without generics? Can I do, like, the calls without having to rely on generics, but instead, like, passing in an array list of the components I want? World. Okay, we'll look at world. See, this will either be the reason why I make my 3-month deadline, or it will be the reason I completely fail it. One way or the other. One thing's for sure, this will be a lot more solid than the entity component system I have implemented right now, I still could do my idea to abstract away the ECS system and make it actually easy for people to use. That would still work in this case. Okay, so we have add observer trigger. Triggers the given event, which will run any observers watching for it. That's interesting. I do want to do event type things. I don't know if events are going to be part of the language, like the Brane script language itself, or extra grammar that I put on top of it. We can register system, register boxed system, run system, run stored systems by their system ID. So this is like manually run a loaded system. Okay, so the other part of it is, you guys obviously want to work with me on what you're working on. And that's why you're like going so hard on trying to convince me to use Rust. Not only because you guys are part of the Rust cult, but like that's the other reason. So it's like, what are your goals with your project? Does it have to run on WebAssembly? Because if it does have to run on WebAssembly, like, there's no chance that what I'm working on will run on WebAssembly anytime soon. Like, there's a number of reasons why it doesn't compile to WebAssembly. To deduplicate work is a very valid reason. But I have to say, like, I have very strong opinions about what I'm trying to do, so it's like, I'm going to continue doing what I'm trying to do, and if you guys also want to work on what I'm trying to do, they're really cool, I would like to work with you, but like, there's not much room for me to deviate to like, fulfill what other people want to do, unless it already fits into the vision of what I want to build. Think it likely that there would be more cross-pollination of our projects? Yeah, probably. Like, for example, if we get good IK. Could see that. I don't know, I'm talking to John Standable at some point in the future here. I want to see if I can use his stuff. I don't know, I have a pretty good scripting language that I'm going to be, like, working on here. You might want to use my scripting language. Alright, what's the name of, like, the entities for each command? Because I'm scrolling through this for too long. Like, what specific group of methods am I looking for here? Like, right. The wasm bullishness does make it harder, because I'm very bullish on, like, pure, like, efficiency. Search dynamic? Okay. Well, that is... Or you're saying search dynamic. Get many entities dynamic. Entities... Oh, that's getting entities. We don't want to get entities. We want to get all components with. Oh, in the search bar? Then do I still want dynamic component fetch? Oh, this is a trait. Types that can be used to fetch components from an entity dynamically by component ID. So I would have to... Basically, components and systems can be dynamically typed. Also be type reflected, which is similar. Okay. I just don't fully understand why this is an interface, or where I would put it. Because what I really want is just like a for each call that I can do from anywhere. And yeah. That's about it. Like, I see that, and that's what I need. So what's the, what is the actual for each call? Are they called queries? Like, that's what I need to know. Is, what is the equivalent of Unity's for each call in Bevy? So this is the entity component system that I know. So their world system literally just has a function called it's like entities for each. So you have a system with the entities. The entities is essentially your world. You go for each. You pass in a lambda with a with the components you want, and depending on the type specifiers you put on there, whether in or ref. So ref is mutable, in is non-mutable. This gets run on everything. Okay, so it's query. Query provides an iterator over components from all the entities. Okay, and then do queries have any, I guess, scheduling on them? Or are they like block threads? Are they asynchronous? How does the scheduling part come into this? If I go to query builder, I guess with, and I'm guessing you can just put in component IDs here. Yeah, with ID. So this is what I'm looking for. This is exactly what I'm looking for. If you use the scheduler, but you saw you can also manually execute the systems yourself. Manually execute the systems. I don't care about the systems. I care about querying the entity's world. I'm gonna create my own scheduler, and then I just want to be able to query the component system from my already existing scheduler within BraneScript. Like, BraneScript has its own executor and scheduler, and I want the rest of the project to depend on that, and I don't want BraneScript to be dependent on any Bevy systems. You use the dynamic query builder, which is this. Is there a specific, like, dynamic? Linked earlier in a chat link. Can you just DM it to me on Discord, since YouTube is not happy with links. Not shadow banned. It's literally like, I don't even see mod actions. It doesn't even tell me that it's not letting you post links. Okay, let's look at this. It's funny how, like, in the, like, Discord streamer mode, like, some people's names it will completely, like, censor out, and then other people it will just, like, show their entire name, like here it's like, look, we have all these people that we have no clue who they are, and then they're just Ridge. Just shamelessly doxing Ridge. Cade would approve if he's still in chat. Okay, so standard way of defining a query is by using them as system parameters. So the system, does that essentially make it so the system doesn't run into that until that query is ready to be run? No, the system wouldn't be run. The query would just be empty. Would run. The query would just be empty. Wait, so I guess what I'm saying is, if other systems have locks on the contents of the query would still, the system would still run, but the query would be empty. Is the bit right above transmutation? Yeah, IIT. Entity rev. This is where we get the pointer to the actual component ID. Okay. So now I have them. Now I have the actual memory for the component I want. Okay, so the query just takes in a world. User query is literally just a string. Diversity with get with short type name path name. So I'm guessing this is passing in a name of components to search for. And then we're going through and we're getting those components by their ID. Okay, I understand this. Then we build a new filtered entity reference query. That's your standard, like, only run on these entities in this world. Build with this ID. So I guess this isn't for multiple types. What does this split into? Split. Oh, it's just taking the first argument. That's a weird way to just get the first type. Get that component, build, then we just do for each. And then we're able to access the world from X outside of a system. Like, I don't even need to use the system's system. I could just wrap a bunch of, like, API for my scripting system in here, and then do that. Nice. Simplest world new. I don't think I need to have multiple worlds. I was originally thinking that I would need to do multiple worlds to properly, like, keep chunks like sandbox from each other, but I'm going to get around that by, like, obfuscating the fact that it's actually ECS behind the scenes by just, like, letting people put components on objects, and then those objects run the systems on only those objects. So it kind of, like, you don't have some of, like, that, like, oh, I can just have a position on these things, and then I add, like, a movement component, and then everything with a position and movement will have the movement system run on them. It does remove that aspect of it, because, like, I honestly think that's, like, undesirable for, like, a sandboxed environment, which is what I'm building. Because then you get stuff like, oh no, this block of chunks over here is, like, causing problems for this chunk of blocks, or this chunk over here, because this one loaded a system that accidentally is affecting these ones over here. No, I'm gonna keep it, like, very, very intentional on the part of the devs. So I do think I can put everything in one world, because from the API I give them, it won't be possible for them to mess with other worlds. or other chunks, I should say. But the ability to still have multiple worlds is good, cause, like, in editor stuff. Or, like, let's say I have a UI system, that might be its own world. Okay, yeah, that's basically everything I needed to be able to port my stuff over. Because, like, is it just Butler? Is that how you say it? I haven't said it yet. The Butler pointed out that there is... Because, like, my justification for not using Rust was literally just the fact that there weren't good orc bindings in Rust. But apparently there are, and I just haven't been able to find them. So I could just use, like, this even has, LLJIT, which there's a C class called LLJIT, which is literally what I'm currently using to run code. So that, like, 1-to-1 could just port it over. Hey look, what's that? It's a Rust-style enum. Hey, let's look at, you haven't seen this code base. Here, let me show you some other stuff that you'll find interesting. It wouldn't be runtime. Let's look at document context. Hey, what's that? These look rather familiar. I think if we go maybe to the parser, there's this is parser H, yeah. There's a lot of options. I have a result type in here too. I'm trying to show you that there's a result type. Because my brain was oxidized. Like, I don't want to have to deal with I like literally just don't want to have to deal with like overloaded types and pointer casting. I want to do enum matches. Like, this is dangerous. This is dangerous for me because how does this affect the timeline? See, the thing is, it might not actually affect it too much, because like I can write thousands of lines of code in a day, as long as I like know what I'm doing as the design part that takes most of it, or like your option types not being able to return references, but that's not a problem. Okay, let me. As long as I can carry over, this won't be too hard to port. None of this will be too hard to port. It did. I got brainwashed. I thought like I was still somewhat free. Like, oh, I'll continue my project in C++ while like writing love letters to Rust in the code. No, they're pulling me back in. They're like, you know you want to be here. It's already Rust code. It is. What I do have to say about Rust is, I like. Have I told you the story of how before last AWE, I like Sprint wrote an entire networking solution in a month, and then it worked the entire conference without crashing once. And then they're still using it, like, with a couple of bug fixes after there. Like, I left that company. They're still using it. I checked. There literally haven't been any pushes to the codebase except for ones that I've helped with, even after I've left giving advice. And it's still working, apparently. Like, I see money going in and out of, like, the company, like, account, which I still have access to for some reason, because they haven't done anything to actually offboard me. So it's like, I know I can build stuff fast. And I was already halfway through a giant refactor of the engine that I stopped because I wanted, like, parsing to work the way it did in Rust. And then I was like, oh, I'll just rewrite all of that in Brane script so that I don't have to rewrite it in Rust. I could just finish that refactor and have it be in Rust. I would have to rewrite all of the IM GUI code, but that's not too big of a deal. Screw you guys. They figure they would want to call you up if something goes wrong, but they don't have any money to pay me to fix it. See, that's the problem. That's why I left. Even though I was literally the CTO. Like, there was zero money in that company. Negative money for, like, over half a year. I don't want to have to deal with that anymore. Like, I feel bad for some of the employees, so, like, I help them. But, yeah. Yeah. How fast can I rewrite a code base of 20,000 lines of code? Screw you guys. Dang it. It isn't even a big company. It's like a startup of, I think, literally like 3, maybe 4 people at this point. Well, see, I have a 4-month deadline here. Like, I was going to go to AWE and, like, show stuff off. Switching to Rust solves a lot of problems, though. Thought it made this the right decision to stay in C++ because I already have code there, except I'm refactoring every line of code in the C++ code base. That doesn't matter. All of the low-level languages has that crowd. What are you talking about? Post AWE note, refactor the whole thing in Rust. Think about it. Way of the future is it worth the same C++ if you're going to end up switching anyways. I wasn't planning to ever switch, though. I was just planning to make, like, a really good scripting language that was essentially Rust, but for game devs, and then call it a day. And just use the scripting language for everything, because it's going to be a really fast scripting language. It's still going to be a really fast scripting language if I switch over to Rust. Dang it, I don't have any excuses, I have to do it now. I have to make some really good progress, though. Because, like, switching languages is very much like a things that tanked a project thing to do. Oh, C++ is definitely slowing me down, like a ton. Like, I have had so many issues with the language recently. do it in C++, they said, we don't have to redo it in Rust later, they said. Imagine if I just gone, oh, I'm rewriting it in Rust, like, 3 months ago. I would be done. I already have ECS pre-built in C++. Like, my ECS was working fully. I already had it. Now, will it break down under the load of, like, production? Maybe. But I already built all of it. Is it good and fully featured, though? It can do a for each, and that's all I need it to do. So the answer is fully featured. By your definition, probably no. Holding 8 concurrent viewers right now. You guys just all wanting to watch me get brainwashed here? Is that what's going on? Just watch, like, enjoying watching my mental suffering? Everyone heard Rust and poured in. The algorithm can't sense what I'm... Can it? Can the algorithm? Is the algorithm just running constant closed captions on me? And then recommending people based on what I say? I'm pretty sure no, I have it on ultra low latency, which in subtext says does not support closed captioning. Yeah, so they're not closed captioning me. They don't know. They don't know what I'm saying. The algorithm put us in this chat that commits you. No, it didn't. You DM'd me on Discord. Or no, the butler DM'd me on Discord. And then the two of you hopped in here. You were like... You probably saw me in the Discord sidebar, and you wanted to induct me. Which, you were successful. Thank you. Maybe. Screw you guys. Oh, but there's a solid chance that I could name a video I rewrote it in Rust. And that hurts me so bad. Oh no, I already am. Custom scripting language, huh? The Rust? God, say something. My metaverse engine wasn't working, so I rewrote all of it in Rust, and I got a demo working at AWE. Really don't want to be fighting a scripting language right now, or coding language, and by that I mean C++, because Rust works with my brain very well. And then I went back to C++ and I'm like, this doesn't work with my brain very well. Half your messages are shadow banned? Like, okay, here, look at this. So I go here, moderation activity. I automatically see shadow banning activity. I know because like Jack came in here and like he got moderated, but look at this. I have moderation activity on, and I don't see anything from you that like has a label on it that says comment held for review or anything. You're not getting shadow banned. You're just cringe. I wonder if I can do anything like to say let this user say whatever they want except slurs. It would let me, add you as moderator. But screw you, I'm not doing that. But that's not even moderatable. Like, dude, that is a message that should be sent in chat. Why are they banning that? Here, let me see. Do I have a way to we have seed phrase blocked. Moderation basic. I just put it on none for now. We'll see if that actually affects anything. Maybe you were just like spamming all cap stuff. Oh wait. What are you saying is shadow banned? It's right here. Like, I can see it. I see your own language, but you don't. Sounds like a personal skill issue. Show up in your custom UI thing? It isn't a custom UI thing, it's just a regular YouTube chat. I bet other people saw it, and it just, like, was bugged out for you. I don't know. Okay, so I need, like, an actual plan now, because I need to, like, work very, very quickly here. If I want... Because, like, okay. I need to, like, send messages back to the people about, like, potentially seeing if I can get a discount on their gamer booths. Because they're like 4K. I can't afford 4K right now. I might be able to afford 4K then. But I also like am in the middle of buying Burning Man tickets right now, so alright, farewell. Just gonna dip out after like giving me a project crisis here. I wish you a rusty day. Was I gonna search up? Right. So when is AWE? Oh, those are their cheap booths. Here, let me bring up the document. The document. So if we bring up the session expired. Don't session expire my work email. There we go. Let's see. Just like, I saw your note about having a game you'd like to come. It's a game engine, okay? It's an engine. It's much more flashy than a game. But anyway, they gave me this document. Which page was it? 12 of the prospects. Whatever thing this is. So yeah, it's like, you get $6,000 in value. So it's like $3,700, and you get 10 feet of space, so you can put somebody in a headset, electricity, Wi-Fi, there's a bar nearby, branded signage in your space. Ooh, wait, they print that out for you? That was like one of the things I was like, oh, I'm gonna have to like figure out where to source that. But no, I could do that. Just let them do it. Or how many ChatGPT reskins of AW Asia 2026 will have after the success of DeepSeek? I don't know. Is AWE isn't an AI conference? It's AR, right? There's no AI there. Stay out of my industry. But this very expensive, and the founder like booths are like 3K, and this is only 700 more, and it's like has power, which is pretty important. The union at this conference hall did kind of like screw over a lot of the vendors last year too, so that is something that I'd be worried about, is like having several $1,000s of extra cost on top of this. That's just like, we had to plug in your electricity for you. That'll be $500. But I need to actually respond to this dude. Right. But I did need to figure out, like, how much time do I have? Do I think I can literally switch to an entirely new coding language? And there we go, June 10th. Oh. So it's currently March, April, May, June 10th. 1, 2, 3. I have 3 months. Can I get this working in 3 months? Am I willing to bet $4,000 that I can get this working in 3 months? I definitely can't get them to hold a spot for me and then dip out at the last moment. Well, maybe if I hook up an AI chatbot to... No. Actually, that might actually be how I could get it working. Just hook up chatbot to my editor and help me write a ton of boilerplate. Convert this code to Rust. Convert this code to Rust. Convert this code to Rust. United XR Europe date? December? I would have deadlines I would want to hit before then. Like, there's several hackathons I would want to bring this to, like the Stanford hackathon is in October. Or September? It might be, I think it might be September. Yeah, like, I want to get it to the Stanford Immerse the Bay, which is to be announced. Three months. Can I do 3 months? I've been, honestly, most of my slowdowns have been fighting the language. How fast do I think I can port everything? For specifically, Brane script, I think I can have this ported in, no joke, a day. Like, I could get this ported in a day. Or 2 days. If everything works how I expected, I could get that ported in 2 days. Just if the code is flying from my fingertips. And potentially with, like, some non-human help. Where I just say, convert this to Rust, convert this to Rust, convert this to Rust, convert all of it to Rust. Because all of these are like match statements, It's already Rust. Half of this even gets easier to work with because I don't have to split it into header and source files. True, they could help out, but I'm trying to hit a 3-month deadline here. It's 3 months now. It was 4 months, but now it's 3 months. Like, I need to get this working yesterday. And I legitimately, like, the problem is, now that I know there's actually decent LLVM bindings, I could legitimately do this a lot faster in Rust. It would make a banger of a video, though. The metaverse is built on crab. I would just film the entire video in a crab avatar. Here. 1 second. I should have done this much sooner in this stream. There we go. That is me. Hello. I am Crab. Hello everybody, welcome to my Rust stream. Today we are considering the possibilities of turning all of my code, 3 years of work, into Rust, because I'm already rewriting all of it in C++. Might as well rewrite it in Rust. Okay. You know, I'm not getting anything useful done right now at all, because I have the, like, dang, now I have to rewrite all of this in another language block. So I probably should end the stream here, and, consider my life choices. Indeed, indeed. This is my superior form. I should just do... At this point, like, the next stream is going to be called Rewriting My Entire Engine in Rust, and I should just do it in this avatar the entire time. It's, like, not a very, I need a better crab avatar. I need help finding a better crab avatar. If I find a better crab avatar, we'll do the crab Rewriting in Rust stream. Alright, with that... I'm gonna sign off. This was derailed.